everyone. Today we're going to go ahead and go over complex numbers, lesson 4-4. So let's go ahead and get started. Some important vocabulary we're actually going to look at today is an imaginary unit. We are looking at imaginary numbers today. And we're going to look at pure imaginary numbers as well as a complex number. And of course, we're also going to look at complex conjugates. So the first thing we're going to take a look at is the square root of negative numbers. So we're going to simplify the square root of negative 28. We can actually break this up into the factors of negative 28. And so we're always going to, whenever we have a negative, we're always going to pull out negative 1. And that is because the square root of negative 1 is I, which is imaginary. So this is very important to know that the square root of negative 1 just equals I, which is for the imaginary number. And so a long time ago, somebody just got really upset that they couldn't take square roots or work with negative numbers the way that we work with positive numbers. And so they came up with I for imaginary. So we're going to break up the factors into 3 other square roots here. So we're going to take the square root of negative 1, the square root of 2 squared, which is 4, is another way to think of it, times the square root of 7. By properties of radicals, we can just multiply everything that's on the inside of the radicals together, and also to break it up into factors so we can make it easier on ourselves. So we're going to pull out the square root of negative 1, which is I, and the square root of 2 squared, or also known as square root of 4, is 2. And we're going to leave square root of 7 alone. So our answer is 2i square root of 7. All right, so our next example is a square root of negative 32. We can break this up into negative 1 times 4 squared. 4 squared is 16, and then times 2, because 16 times 2 equals 32. Is something that we can all remember. So we're going to head and move on. Breaking up into the 3 different radicals, and we're going to take each separate square root. So we're going to get I times 4 times square root of 2, which is just 4i square root of 2. All right, so let's go ahead and try the square root of negative 50. I'll give you a moment to try it. Pause as needed, as usual. All right, so when I take a look at square root of 50, negative 50. So I can break up negative 50 to negative 1 times the square root of 25. And I like it writing it this way a bit more instead of writing it as the perfect square because it's easier to think of, times the square root of 2. So the square root of negative 1 is I, the square root of 25 is 5, and we're going to leave square root of 2 alone. So our final answer is 5i square root of 2, which is C. All right, go ahead and try the square root of negative 45. All right, so we're going to break this up into the square root of negative 1, the square root of, I'm going to use negative or positive 9 times 5. And pretty much what we're always trying to do here is find a perfect square that multiplies into our given. So I know 9 times 5 is 45, and 9 is a perfect square. So we get I times 3 times square root of 5, which is just 3i square root of 5, which gets us A. And so now we're going to take a look at pure imaginary numbers. So we're going to simplify negative I times 2i. And what we really need to remember here is that I squared equals negative 1, and that the square root of negative 1 equals I. And the reason we write, by the way, we write our i's this way so that we know that we're talking specifically about imaginary numbers. In the PowerPoint, you'll notice that they're using bolded i's. But when we're writing this usually by hand, we do a little curly I so that we know we are talking about imaginary numbers and not just the letter I. So we're going to go ahead and we're going to multiply like with like. So we're going to do -3 times 2 to get -6, and I times I to get I squared. And as a reminder, I squared is -1, so this is really saying -6 times -1, and we get +6 for our answer. Next, we're going to take a look at -12 times -2, square root of -2. So we're going to go ahead and multiply these two. We're going to pull out the i's. So pretty much anytime we have a negative radical, we are going to go ahead and pull out I in the front. And then we're going to multiply like with like. So I have I times I and square root of 12 times square root of 2, which gets me I squared square root of 24. I can simplify again that I squared equals -1. So we're going to go ahead and simplify that. And then we're going to break up 24 into 4 times 6 to pull out a 2, and we get -2 square root of 6 is our simplified form. And we usually, when they do say simplified, they do want the most simplified version of the variable or our expression. So go ahead and try doing 3i times 5i. All right, so we're going to multiply like with like. So I'm going to do 3 with 3, and then the I with the I. So I'm going to get 15 I squared, which is just 15 times -1, which is -15. So our answer is B. We're going to simplify -2, square root of -2 times square root of -6. All right, so the first thing we're going to do is pull out the i's. So we get square root of 2 times I square root of 6. Like with like, so I get I squared and the square root of 12. I squared is -1. Square root of 12 can be rewritten as square root of 4 times square root of 3, because 4 times 3 is 12. And so we get -1 times 2 times square root of 3, which is just -2 square root of 3. So our answer is B. So we'll go ahead and solve quadratics that are going to have imaginary solutions, meaning that I is going to be in our answer. So we have our original equation of 5y squared plus 20 equals 0. This is a quadratic because it has an exponent of 2, even though it has y instead of x. That is completely fine. So we're going to subtract -20 from both sides, or subtract 20 from both sides to get 5y squared equals -20. We're then going to divide each side by 5 to get y squared equals -4. And to undo a square, we take the square root. So we're square root both sides, and we get plus or minus the square root of -4. And then we simplify that to plus or minus 2i, because the square root of 4 is 2, and the square root of -1 is I. So y equals plus or minus 2i. All right, so go ahead and try this one. 2x squared plus 50 equals 0. All right, so let's go ahead and work this one out. The first thing we're going to do is subtract 50 from both sides so that we get 2x squared equals -50. Next, we're going to go ahead and divide by 2 so that we have x squared equals -25. We're then going to take the square root of both sides to get x equals the square root of -25, which we can simplify this to the square root of -1 and the square root of 25. And this gets us plus or minus 5i. So our answer is A. Here we have is that anytime you take the square root of a negative, you should probably have I unless you're doing multiple square roots of negatives. So here we have our key concept of complex numbers. And a complex number is any number that can be written in the form of a plus bi, where a and b are real numbers and I is an imaginary unit. A is called the real part and b is called the imaginary part. So it's like a binomial, but it's not quite a binomial per se. But 5 plus 2i would be a complex number. Again, pause as needed if you need time to go ahead and write this down. So we're going to find the values of x and y that make the equation 2x plus y, I equals negative 14 minus 3i true. So we're going to set the real parts, which is 2x and negative 14 equal to each other. And then we're going to go ahead and press the imaginary parts equal to each other. So we're going to do 2x equals negative 14 and solve for x and get negative 7 because we're going to divide each side by 2. We're then going to set the imaginary sides equal to each other. And we're not going to worry about the I because we have yi equals negative 3i. The i's cancel out. And we're left with negative 3. So go ahead and find the values of x and y that make the equation 3x minus yi equals 15 plus 2i true. All right, so we're going to set again imaginary with imaginary, which is going to be negative y equals 2. So y equals negative 2. So this negative gets applied to this y here. And we're also going to set real with real. So I'm going to do that back in red. 3x equals 15. Divide by 3. And we get x equals 5. So our answer is D. Right, next, we're going to add and subtract complex numbers. We're going to do like with like. So we're going to do the 3 with the 2. And the 5i with the negative 4i, which is what they have done. So real with real, imaginary with imaginary. 3 plus 2 is 5, and 5 minus 4 is just 1, so 5 plus I is my answer. Next, we're going to go ahead and subtract. Again, we're going to do imaginary with imaginary. And real with real. And one of the key things we do need to remember here is that we are subtracting. So we are going to be subtracting numbers. So we're going to do 4 minus 3, negative 6i minus negative 7i, which would make us go ahead and add because minus and negative is like adding. And then again, we're going to get 1 plus I for our solution this time. Again, because 4 minus 3 equals 1, negative 6 plus 7 equals 1. So we just have 1i. All right, go ahead and simplify 2 plus 6i plus 3 plus 4i. All right, so we're going to do real with real. So I'm going to do 2 plus 3, and that gets me 5. And then we're going to do imaginary with imaginary. So I'm going to get plus 6i plus 4i, which gets me 10i. So you can treat I like a variable. You're just going to add the coefficients and multiply the coefficients as such. And with that, we get D. Right, go ahead and simplify 3 plus 2i minus negative 2 plus 5i. So we're going to do real with real here. We're going to do 3 minus negative 2, which is 3 plus 2, which just gets me 5. And then we're going to do, on our blue, we're going to add 2i minus 5i. So we get 2i minus 5i, which is just negative 3i. So our final answer is 5 minus 3i, which is B. All right, sorry about that. Next, we're going to take a look at example 6, which is using in real-world application of multiplying complex numbers. So in AC circuit, the voltage E, current I, and impedance Z are related by the formula E equals I times Z. Find the voltage of a circuit with the currents of 1 plus 4 joules amps and impedance of 3 minus 6 J ohms. J is usually used for joules in physics. Ohms and amps are measurements. So we're just going to go ahead and multiply our amps and our ohms. So we're going to do 1 plus 4J times 3 minus 6J. We're actually not going to FOIL here. It's great when we're doing two binomials. It doesn't really work for us when we have something higher than a binomial. So what we're going to take a look at is actually the box method. It's the same thing as FOIL, it's just set up differently. And so we're going to do 1 plus 4J, and we're going to do 3 minus 6J. And we're just going to go ahead and multiply. 3 times 1 is 3. 4 times 4J is 12J. 1 times negative 6J is negative 6J. And negative 6 times 4 is negative 24. And then J times J is J squared. Which is the same thing they got when they used FOIL. It's just that's not something we would like to focus on anymore, just because, again, when we move forward, FOIL doesn't really work for us once we get out of binomials. But they still also end up with 3 minus 6J plus 12J minus 24J squared. And we are going to treat J as I, so J squared is going to equal negative 1. So when we do that, we end up with minus 24 times negative 1, which is plus 24. So 24 plus 3 is 27. So the voltage here is 27 plus 6J volts. So go ahead and try this one. This time you're going to have 1 minus 3J for amps and 3 plus 2J for ohms. So let's go ahead and work this one out. We're going to go ahead and multiply. We're going to get E equals 1 minus 3J times 3 plus 2J. Again, we're treating J like I. So I'm going to go ahead and set up my box. So I'm going to do 1 minus 3J and 3 plus 2J. So 3 times 1 is 3. 3 times negative 3J is negative 9J. 1 times 2J is 2J. 2J times negative 3J is negative 6J squared. So we combine like terms, we have 3, and then we're going to add 2J and negative 9J to get negative 7J minus 6J squared. So we're going to go ahead and change our J squared to negative 1. which gets us 3 minus 7j, 6, which gets us 9 minus 7j when we combine like terms. And we see that our answer will be B. All right, next we're going to take a look at division. So we've now added, subtracted, multiplied, and of course now we're going to divide. To do this, we actually need to remind ourselves what a conjugate is. So an example of a conjugate would be 3x plus 2, and then 3x minus 2. So when we're looking for a conjugate of a binomial, you're going to take those two terms and just switch the sign in between of them. So what we're going to do here is we're going to multiply by the number 1, but we're going to use the conjugate of our denominator. That way when we multiply, that our middle terms of I will disappear. So one of the rules we have again is in math we're really picky and we don't like having anything weird in the denominator, which would include imaginary numbers. So when we multiply by the conjugate, we'll end up having a difference of 2 squares, which means we take the square of the first two because they're exactly the same, and then we're going to take the square of the last two, because when we do multiply by the conjugate, and I'll go ahead and show you that, the middle term will disappear, so that's why we call it a difference of 2 squares. So we're going to do 3 plus 2i and 3 minus 2i. And we'll get 9, positive 6i, negative 6i, and then negative 4i squared. So notice these are going to cancel each other out, and we're left only with the square of the first and the last. So that's how we get 9 minus 4i squared, and they're going to do 5i times 3, 5i times negative 2i, to get 15i minus 10i squared. So when we go ahead and simplify this, because we know I squared is negative 1, we end up with 15i plus 10 over 13. And if they want it in a plus bi form, we are going to have to write it in fractions. And so that just means we split between the symbol of our addition or subtraction and make our denominator the same on both. So 10 over 13 plus 15 over 13i is our answer. So now we have another one. We have 5 plus I over 2i. We're just going to go ahead and multiply by I over I. So as a reminder, anything divided by itself is 1. So we're multiplying by 1 here, but we want to look a little nicer. And that's going to be the easiest way to cancel out imaginary numbers is multiplying by I. So we get 5i plus I squared over 2i squared. This is simplified to 5i minus 1 over negative 2. We're going to separate it into 2 fractions to get 1 over 2 minus 5 over 2i. And we get 1/2 minus 5/2 I. And again, the reason we like it in the form of a plus bi, or minus in this case. All right, so go ahead and try 3i over 1 plus I and simplify that, please. All right, so the first thing we identify is our conjugate. So our conjugate here is going to be 1 minus I. So we're going to multiply top and bottom by our conjugate. If you're somebody who needs to make sure you know your ones, go ahead and make sure you do that. We'll multiply by the conjugate in the numerator and the denominator. And so I'm going to do 3i times 1, which is just 3i. 3i times negative I gets me minus 3i squared. And I'm going to have a difference of 2 squares, so I'm going to do 1 times 1, which is 1, and then minus I times negative I, which is negative I squared. So I'm going to replace the I squareds with negative 1. Right, so we're going to head and simplify, and we get 3i plus 3 over 1 minus negative 1, which is a plus, which is 2. So we're going to change this into 3 halves plus 3i over 2. So our answer is A. All right, now we're going to head and simplify 3 plus 2i over 2i. All right, so we're going to head and multiply top and bottom by I. When we do that, we're going to get 3i plus 2i squared over 2i squared. And then we're going to head and replace the I squareds with negative 1. So we get 3i plus 2 times negative 1 over 2 times negative 1. You may be tempted to cancel these out, but we're not able to do that because we are dealing with a binomial and a monomial. So we're not able to actually do that. And so we're going to end up with negative 2 plus 3i all over negative 2. So we're going to go ahead and put that into two different fractions. So negative 2 over negative 2 plus 3i over negative 2. And so we're going to go ahead and simplify that. Negative 2 divided by itself is positive 1. And we're going to go ahead and move our negative to the front. So we get negative minus 3 halves I, which gets us B, I minus 3 halves I. And that is the end of our notes today. And I will see you guys next time.